Urbit is a completely new way of looking at computing. Every user gets a personal server which runs your apps, wrangles your connected devices, and defines your secure identity. Your Urbit presents your whole digital life as a single web service. Urbit feels foreign and confusing for those of us coming from traditional web backgrounds. But that's because the normal paradigm is to iterate and paper over the problems of the current platform with new things built on top. Curtis Yarvin, the creator of Urbit, argues that the current model is too fundamentally broken for the iteration strategy to work. As he says, the internet as a client-server network has won. The internet as a peer-to-peer network has failed. This sounds like yet another quirky, overambitious developer side project, but Urbit has serious legs. The GitHub repo has had 51 committers over its 4 years of activity. Last year, a public crowdsale of Urbit address space raised more than $200,000. Peter Thiel was an early investor in the project, perhaps partly due to the combination of persistence, technical skill, and unusual opinions of Curtis Yarvin. In this episode, Curtis and Galen Wolfe-Pauly join me for a conversation about Urbit, its strange computing platform, and the contrarian philosophies that drive its creators. Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/sedaily. Hired makes finding a new job enjoyable, and Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/sedaily to get advantage of that special offer. And thanks to Hired for being a continued longtime sponsor of Software Engineering Daily. Curtis Yarvin and Galen Wolfe-Pauly work on Urbit. Guys, welcome to Software Engineering Daily.
Thanks for having us.
Yeah, thanks. Glad to be here.
A quote from the Urbit documentation. The internet as a client-server network has won. The internet as a peer-to-peer network has failed. What does that mean?
That's a good question and a great way to start. I mean, back when I was learning to use the internet in the 80s, I think it was sort of everyone's impression that when we used the internet, we would have our own nodes that actually exchanged, IP packets, and that didn't exactly happen. Instead, what happened is, a good way to say this, sort of from the 80s perspective, is imagine, you went to sleep in 1988 and did your Rip Van Winkle act and woke up today. How would I explain the world to you? And well, what I could say is, okay, we have this new kind of modem. It's called the internet. It doesn't go dee-doo, 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 dee-doo. You can connect to many online services at the same time. There's a standard client for all online services. And CompuServe is now called Facebook, and nothing else has changed. And so really it's like we sort of, from the perspective of being someone from that Stone Age, it sort of felt like there was this revolution that was going to happen, and it kind of started to happen, and some amazing things happened, and then we ended up with sort of boring old feudalism again. And so really the kind of the fundamental technical motivation comes from what caused that to happen, and how can we basically try again and make sure it doesn't happen.
When I started to look into Urbit, I slowly realized that this is a giant project, and it's not just a vaporware giant project. It's a giant project with a lot of work behind it, a lot of man hours at this point. And so it got me really taking it seriously, and I was like, so what point is this project trying to make? And I think I started to get it when I read, so the idea of a peer-to-peer network that you want is point-to-point communication between peers, whereas today we have all of our communication, but if I want to communicate with your entity, I need to go through the broker of Facebook, for example. And in your ideal, the peer-to-peer network would allow for more direct communication between each other. Is that accurate?
That is accurate. So, I mean, the thing is, an example of kind of a relic of the old days that's kind of survived into the new world is email, right? And email is still, sort of barely a peer-to-peer network, as in you can run your own email server. I wouldn't recommend it. I don't think many people recommend it. And, in practice, if you're running your own email server, Gmail is going to be pretty suspicious of you. In practice, it makes a lot more sense just to sort of forget about this peer-to-peer thing and just, sign up with a big G. And one way to sort of look at that, which is interesting, is to say, well, we had this service, which was email, which was totally peer-to-peer. And then the internet kind of, exploded. And we sort of kept email. Email kind of got grandfathered into the new world as a protocol that's still vestigially peer-to-peer because it already existed. But you can't create a new open protocol like email today. And, you see the various attempts to standardize kind of, instant messaging and presence, as we used to call it back in the late 90s. And they totally, failed. Like you couldn't, and occasionally one of these big servers will kind of try to open federation of their instant messaging. Nothing but spam will come through. They're like, we tried, looks like the internet did fail after all. And, in a way, it's this sort of dystopian, vision. I mean, I remember, I think it was back in, must have been 1998. I was in an ITF, working group on instant messaging and presence. And, all these people had, they were like XMPP, which was Jabber then, was just starting to become standardized. People are like, people saw the internet, taking over the world back then, obviously, and they assumed that since the internet would take over the world, the IETF would take over the world, and therefore, in this little room, people would define what protocol was used for peer-to-peer instant messaging. And if you could go back in time and tell those people, well, actually, there won't be a protocol, there will just be one monopoly server, which is, being imagined in the head of a 14-year-old right now. I think that people would be very, disappointed. And so the critical question in my mind is, it's like, I think a lot of people look at this sort of failure of the internet to become what it was supposed to be. And for some reason, they sort of want to try the same thing over again, or they attribute it to, they think of it as a coincidence, or maybe it was done by Russian hackers or something. I think that those of us who sort of grew up believing in Unix and the internet basically need to take a hard look at this technology base and say, why didn't this work out the way we wanted it to? Was it just a coincidence, or was it basically the fact that these essentially 70s technologies of Unix and the internet, sort of scaled in theory to this global peer-to-peer network, but didn't actually scale in practice? And so, that involves basically like looking at a fundamental level of saying, well, why can't you introduce a new federated protocol on the internet today? Why can't people have their own servers on the internet today, right?
And just to simplify things for people who are still a little confused, the Urbit model would have everybody having a personal server. And in the current state of computing, what the personal server is embodied as is this combination of all the cloud services I use. It's got, my Dropbox information, my Facebook data, my tweets, all of these different things that are federated out into a variety of services. These compose the union. The union of these is what would be the personal server in the Urbit model.
That's exactly right.
Talk more about why that's important. Why is it problematic that all of this data is spread and federated out across all these different services? And why would it be advantageous to have an alternate model of the personal server?
So Yeah, so I think about this. So I've been reading this history of Bell Labs, which I recommend to just about everybody, and I'm going to forget the title, but it's like the most recent one. And so early on in the history of Bell Labs, I've been reading about how like the phone system was completely fragmented, right? So people literally had to have separate phone lines to communicate with different people because there was no like universal standard for how people would send voice, right? Like different companies actually owned the wires. And when I was reading that, I was like, oh, that's exactly what I experienced today, right? Like if I want to send someone, I was just trying to set up I was trying to figure out how to message with a contractor, and it's like, my SMS isn't working, so can you talk to me over WhatsApp? And to me, that's like, it's so insane to me that these things, it's sort of, in general, what we think of as social networking, but I think it's much broader than that. It's like what we think of as cloud computing, like hasn't been sort of standardized into some kind of protocol that encompasses basically identity, messaging, computation, and data storage, right? We all use these things, but our ability to use them is kind of moderated by these giant services that provide the interface, that decide how we can use them. And so because that has to be done by a single centralized entity, it's very difficult to basically innovate on top of that, to innovate like at the actual user level, right? To provide new user experiences, you have to effectively build an entire company.
Sure. So, I mean, the user experience of using all these services, of sort of switching between these services is kind of terrible because you have, and, one of the things about terrible user experiences is that basically people don't realize how terrible they are when they're in them. They only realize, if everyone is sort of used to the discomforts of their ordinary lives. And so it's like when you get outside those discomforts, you're like, wow, that was really uncomfortable. But until that experience is there, you don't really experience it. And so the things that fall out of this kind of bad user experience are, of course, so you have these, 10 different accounts. So there's this sort of pain of kind of switching between each of them and, basically being like, oh, is this here? Is this there? Do I use this? Do I use that? That's a sort of, pretty trivial form of pain. There's definitely the fact that when you use a special purpose service, that service owns you and controls your data in a way. And that produces, most people sort of think of those bad effects and kind of in terms of, privacy and NSA and whatever. And there's certainly truth to that. But it also produces this interesting effect where the service that shows you your UI is not working on behalf of you. It's basically a UI controlled by someone else. So in a world where like you run your own UI, it's sort of much harder to imagine that UI, for example, showing you ads, because why would a UI that worked for you show you ads? Like why would, wouldn't it just lie and say it showed you the ads? So there's a sort of issue of control that is kind of, fundamental to the user experience. And there's something else, which is that when we use all these different user interfaces, basically we have a real resistance to adding to that set. We're like, okay, these are the services that I know. Now I'm going to consider using this different service. I got to learn the UI. I got to, have this experience, right? And it's like, yeah, do I want to put that work in? And what's funny about that is that it used to be somewhat harder to sort of explain this, and then this new service in China appeared in the last really 2 or 3 years. Do you know anything about WeChat? Do you know the? So WeChat has basically. I mean, they haven't actually given everyone their own general purpose computer, but they've sort of created a user experience which is much closer to the user experience of a personal server. So when you use WeChat to consume an online service, they've basically sort of, for a lot of things, for basically most standardized services, they've essentially taken this web model in which you go to a remote third-party origin server, download the UI, run the UI, and they've replaced that with APIs. So what that means in practice is, let's say you use WeChat to do your banking. So if you bank on the web, with, in the US, the way it works is you go to your bank's website. They hired a bunch of JavaScript jockeys to write a UI. Every bank in the US provides the same basic financial services, but every bank in the US has a bunch of JavaScript jockeys that run the UI. So and then you as a user have to learn this new UI, which we think of as an easy task, but those tasks add up. In China, when you're using WeChat, when you go and bank, basically your bank provides an API to WeChat, and the UI is standardized. And so if you want to switch banks, you're just like, oh yeah, let me put in this different account number, and suddenly I'm banking with this different bank. You go to China, and you know, there's a lot of places where you can order food in restaurants through WeChat. Again, same thing. If you're doing it, you know, using the web model, it's like, okay, I'm a restaurant. I want to let people order with their cell phones. Okay, I get to the restaurant. I have to create an account. I sign in. You know, I'm like, okay, I'm, you know, frequent restaurant eater so-and-so. Then, you know, the restaurant hires a bunch of JavaScript jockeys to put their menu in JavaScript, you know, so then I'll order, et cetera, et cetera. And it's just like no one would do that, right? In China, it's like, I want to sell food. Okay, I want to be a restaurant that sells food. Okay, here's how I plug into the API. And there's sort of one user experience, and you just sort of replace the restaurant there. So the thing is that's what's actually going on inside WeChat is not, of course, that you have a general purpose computer that is yours in the cloud that is running an agent that basically orders food on your behalf. It's much cruder than that. But when you see the user experience and you see how well the user experience works for people, you can basically say, okay, this is why we want to go away from this model where your life in the cloud is 10 different accounts, and you want to move to this model where it's one thing. And, you know, it just seems to make a great deal of sense to combine that transition in a user experience with a technical transition where your life in the cloud is becoming a general purpose computer.
Every software project uses email. Every time an e-commerce site processes a transaction or a user makes a comment on a social network, email notifications are sent. SparkPost provides email delivery services for apps and websites. To try SparkPost and send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. SparkPost has a range of pricing options, from free self-service packages to sophisticated enterprise support and services. Start sending emails to your users today. Go to pages.sparkpost.com/sedaily to send 100,000 emails a month for free. Thanks to SparkPost for being a new sponsor of Software Engineering Daily. And if you want to send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. To play the devil's advocate, I mean, with the current model, we have Dropbox, and I pay Dropbox an amount of money every month to be my file storage service of choice. And if they don't do that very well, I can easily migrate my stuff to some other service. So there are market forces that push Dropbox to be better. The same thing is, true for Facebook and Google. I'm giving Google and Facebook my data because I am expecting them to iterate their services at a fast, competitive rate. And so, in some sense, you are federating the responsibilities of your computation to these different domain-specific corporations. And in some sense, if you believe in some efficient market system, then these services are very competitive and they're going to improve over time. And there's nothing wrong with it. And then so certainly, like there are problems with the interfaces that can result because of that, and there would be some advantage to centralizing the interfaces. But then if you centralize the interface in an open source project, perhaps there's you don't get that competitive nature. So I don't know how would this, I don't know, give me some more of a picture for how the Urbit system would evolve and maintain that quality of experience that we get out of this competitive nature.
Well, the thing is, it's a general purpose computer, but that doesn't mean that certainly not you, the user, or even the the OS vendor writes the applications, right? I mean, the thing is that because it's a just because it's a sort of So there's sort of an interesting kind of contradiction in a way. It's like, this is certainly an open system that we're creating. It's not the sort of completely integrated closed thing where Urbit does everything for you. At the same time, when we're introducing this new thing, we have to provide a complete user experience. We can't just sort of build a platform and then let the market do the rest of the work, because the market doesn't exist yet. You have to bootstrap that. But it's certainly true that...
Yeah, so wait. So one way to think about it is basically like, okay, sure, so there are kind of this limited number of actors in this space already. And I would say, well, wait, what if you could just actually move your Facebook data? Or let's say you could actually just move all your Reddit data. So it was really easy to just write a different interface to any one of these things, or even just an extension to one of them, in the way that we expected from like the sort of mid-90s PC era, right? So this was as if it were local data. I could just write another program that operated on stuff that was on my hard drive. So as a creative person, like as a developer, I mean, that's basically kind of what excites me, or what got me interested in Urbit, I think, initially, right? Like, that's an incredible possibility. That's actually what I want to be able to do. And so the fact is that that's, of course, not possible. And so that, in a way, like the market forces sort of can't actually, it's very difficult to unseat these incumbents, because there's the level of lock-in is sort of unbelievable, right?
Right. Nobody can write a new UI for your Facebook data, right? And if that data is on your computer, yes, you can replace that app, and you should replace that app, and it can be made very easy to replace that app. And certainly that's kind of part of Urbit's, technical design, is to really avoid that kind of lock-in at kind of every level. And so,
like, in a way, the proposition is basically, well, we don't really know what's possible or really what we want, because the people, the sort of institutions that have grown up to kind of control this space it's actually incredibly difficult to attack them, or to do better.
I'm sure you guys have heard of power ventures.
Yes.
Yeah. So
very interesting conversation, that could come out of that. But we can have that sooner or later. But yes, very, very, very interesting.
Well,
story.
Okay. So, I mean, I'm sorry to interrupt you, Galen, but just for listeners who don't know, Power Ventures is this thing where this guy was making a feed to unify all your different social networks, Facebook and Twitter and whatnot. And Facebook made him shut down, and he's been fighting Facebook ever since then. He hired a lawyer on Upwork, I think. And he's still fighting this kid.
We hired a lawyer on Upwork, and he wound up being personally liable, I believe, which is quite incredible.
There's a great Planet Money episode about it. But I think we can laugh about this, but it's actually this is kind of gets at the heart of why Urbit could be valuable, because if you rebuild a system in a way that Facebook can't legally just throw a lawsuit at you and prevent you from making a better Facebook with the same kinds of things that Facebook has as a bootstrap, then that's really valuable for users.
Yeah, I mean, Facebook.
Wait. So let me just jump in really quickly. So basically, right. So we've always thought, I think, and so there are plenty of projects who've tried to solve this problem, and I think in most cases they basically have to start from scratch. Like if you're building a new social network, you just assume, okay, you know what, we're going to have to get people to kind of move to this world wholesale. They're going to have to leave everything behind. And I think that one of the sort of really exciting things about Urbit as it starts to become sort of mature enough to actually take this on is that, you're just running a server on the web. I mean, it can do whatever you want. If you want it to go and scrape Facebook for you, then that's completely fine. I mean, that's not our problem. You program this thing, you control it. It's really not up to us what you do with it. So the prospect of actually just sort of layering over all of these services is fantastic to me. I mean, that's really what sort of gets me excited about working on this, right? Is that you'd actually have the potential to sort of to migrate without losing anything, which I think is really, really great. And it's actually, I think, historically also not the way that has happened when you have sort of technical innovations where you're going to, people are kind of moving into some new paradigm. But I think it's fitting for the era that we're in, because the cost of moving is really important to the success of these kinds of projects.
Sure. And when you sort of compare, Urbit to, Power Ventures, like there's in a way, basically, if you're actually, the problem, I mean, there were many problems with the whole, Power Ventures thing, but the real fundamental problem is that, it's very easy for Facebook in practice to sue because it, is kind of this smelly little scam, and it sort of feels and smells like this smelly little scam.
The simple fact is just that there's one person running the servers.
So in a way, it's like the, for example, it's certainly true that a lot of the original momentum behind the VCR came out of basically, people copying movies and such, which Hollywood really didn't like. And so if you'd set up a business that say, okay, I'm going to set up a business to help you copy your movies, that's a business whose sort of purpose is basically to break the law, and Hollywood is not going to have a whole lot of trouble suing that. If you're like, no, I'm going to create a new technology for playing back video, and it so happens that if you can play back video, you can copy it, Hollywood is going to have some difficulty in shutting that down. And because, it's sort of so blatantly anti-technical in a way. And, what's happened with kind of all these giant silos, to sort of bring the conversation back in a technical direction in a way, what's happened with all these giant silos is that they exist because of sort of one very simple fact, which is that it's not really practical for you to run your own node on the internet and to basically control your own sort of computing and to be kind of a digital citizen in a way. And because it's not practical to be a digital citizen, basically you're sort of like a citizen of Rome at the end of the fall, around the fall of the Roman Empire. You're like, okay, I can't protect myself. Who can protect me? I know, King Zuckerberg of the Visigoths can protect me. And so basically you go and you find yourself in this kind of new system of feudalism, and it's not super perfect, right? But on the other hand, you can tend your crops and the Huns don't get you. And so it's like when you're like, okay, we're going to, sort of work very hard to kind of create a world in which we think people can be digital citizens. And then the result of creating that world is that basically people who are digital serfs are going to be like, hey, I could flee to the city and become free. And, that's like that's sort of a way of, you can think of it as a way of attacking Facebook if you like, but I think that it's a way that's sort of appropriate to the scale of the thing that you're attacking, because Facebook is this immense achievement. It's an amazing, work. It's a great kingdom, like I have utmost admiration for sort of the things that they've done there. And, will this kingdom last forever? I don't think so. Is it going to be taken down by, a bunch of scammers in Orange County or wherever? No, I don't think so. And so it's like you have to have that level of ambition, basically.
Well, I think you're getting at some of your philosophies around competition versus like going around and just making something different and perhaps better.
The underlying ambition is definitely like to create a new world, right?
Sure.
And, but you want to do it in such a way that it is in fact so filled with sort of new and different opportunity that that's what causes it to win.
Sure. And the thing is, when it comes to basically APIs, there's of course, the number of web APIs is going up, pretty much exponentially at the moment. And, one way to think about kind of the nature of what a computer is, one way to define like the form factor of a computer is to say, what I/O can this computer perform? So if you're talking about a mainframe, its I/O model is it drives dumb terminals. If you're talking about a PC, it drives a keyboard and a screen. If you're talking about a personal server in today's world, you have to realize that its sort of main form of I/O, besides the sort of web interface by which it talks to the client, is web APIs. And so basically it needs to become natively very, very good at that. And so you basically, when you're thinking about talking to an API from Urbit, you sort of think of it, as almost like a device driver in a way. It's like, this is an I/O channel. And to keep that I/O channel working, you need an API key, you need updates of your API adapters. And to have a system that you can program that can basically drive all of these I/O channels, which is nonetheless sort of a full-fledged, programmable stateful computer, is really something that, kind of nobody has the opportunity to play around with now. I mean, you have, services like If This Then That, which kind of approach that, but they're sort of at a very, very toy kind of level. But I think they really show the potential of what can be done basically with a personal server that's kind of built to drive these APIs.
So the personal server is this system where you've got all the things that you want, all the information you want in your own personal server, and you've also got the API integrations as first-class citizens to these different web things that you want. You've got a first-class citizen API access to Gmail, one to Facebook, and one to Dropbox, all these other things, so that you get the benefits of the present ecosystem, but you get more centralization, more control. So I think at this point, people are probably convinced, okay, this makes sense in some sense. We know why we want to boil the ocean. Let's talk a little bit about how we're going to boil the ocean. Urbit is a clean slate software system defined as a deterministic computer. This sounds like something that would be trending on Hacker News, where somebody's written up a spec and they have no idea how to actually implement it, but there is GitHub code of Urbit.
It actually runs. You can go to urbit.org/stream and you can see people chatting over Urbit.
Right. So, it is a thing. So Urbit is a one-function computer. Let's start there. What does that mean?
What does that mean? It's really actually very simple. It means that your state at any time is a function of your input history. So a simple way for your technically oriented listeners, who I hope are most of your listeners, is, if you imagine you're defining, computing from scratch. Let's look at a computer. Well, I have a computer right in front of me. It has all these different ports and things on it. It has a number of ways of doing this thing called I/O. If you're a sort of enlightened, citizen of the 21st century, you might say, well, I/O, why do we need I/O? Couldn't everything just be a network? And there's actually a very sort of important categorical difference between an I/O bus and a network, which is that a network can drop packets and I/O cannot drop packets. And if you were actually redesigning the hardware from the scratch, let's say you're not just boiling the ocean, you're also burning the land or something, which we're not doing. If you actually got to redesign hardware from scratch, you might well say, well, I have all these cables, all these wires, all these things coming out of my CPU. Let's just make them all Ethernet. Why isn't my monitor cable an Ethernet cable? Why am I not just sending packets to my monitor? Well, probably you could do that. There's maybe a little bit more overhead, whatever. It's fine. We have the protocols we have now. But if you're defining computing abstractly, you're like, yes, what is a computer? Then you have this other sort of complexification, which again comes out of hardware things from really the 60s, which is that you have persistent storage and transient storage. So you're like, okay, my computer has a hard disk, which is slow but lives forever, and it has memory, which is fast, but dies when you turn the power off. HP for a long time, or HP is still working on these things called memristors, which are like, sort of a single level storage, technology that's like as fast as DRAM and as big as a hard disk and will be ready next year, or something like that. But then they're like, okay, what do we run if we have this flat storage system? Well, let's run Linux, because what else would we run? So if you basically take those two abstractions away and you're like, okay, I'm going to imagine I have a computer, it has some state, it has packets in and packets out, and that's all it does. And the state is permanent, it's a single level store. Then you've simplified the problem a great deal. And you're like, okay, how do I define this computer? Well, what you'd really like is basically for the semantics of your computer to be entirely frozen, so that there's no sort of out-of-band update process, nobody coming and slipping in a new disk or whatever. You really want all of the semantics of the computer to be delivered and completely updatable over the network. So that's a, sort of slightly tricky problem. But really what you want is to basically say, get the semantics out of the sort of predefined blob of this definition and get it into something that comes in over this network stream. And then you can basically say, okay, if I include sort of installing and reinstalling the OS, hopefully from source code, as basically part of this stream of packets that I receive, if I also include basically getting the secrets that enables me to decode, the packets, then I can basically say, okay, I'm going to define this whole computer as basically just literally my state is a function of the list of packets that I've received. And you want that function to be as simple as possible. And so I was like, yeah, let's get it to fit on a t-shirt. So I got it to fit on a t-shirt. We should probably be selling those t-shirts. They're pretty cool. Galen designed them. They're pretty cool t-shirts.
They're just the spec.
They're just the spec. So yeah, you can actually make this fit on a t-shirt. And then you're like, okay, so in practice, basically, how do you do this? Well, the sort of fundamental interpreter, which is called Nock, which runs this, you can sort of think of Nock as a very, very simple Lisp. If you can imagine Lisp that's so simple it doesn't even use the lambda calculus. And then you're like, okay, this very, very simple Lisp, which is too simple even to program in, it doesn't even have a syntax. That's sort of the functional assembly language. That's the that's the assembly language of this abstract VM. Then you're like, okay, well, I'm going to ship a higher level programming language that compiles itself to this VM. And then I'm going to write an operating system in this language. And I'm basically going to ship all that stuff in the first few packets to this system. And then basically you have a boot sequence, which is what is needed. You also, to have this sort of be more, this is sort of a nice kind of academic achievement in a way, but that's not really sort of very interesting. You also need all those things to be able to upgrade themselves. So, it's like you can't say, well, it's a lifecycle function. You can, but we actually install the OS in the first 5 packets and then it's permanent. You have to basically be able to upgrade anything that you've installed in that process. And so that's basically what gets you to this sort of, kind of slightly magical otherworldly experience of this this lifecycle function. It's pretty unusual. Did that answer some of the question?
I mean, with Urbit, every answer is 3 more questions to ask. Sure. So there's a virtual machine called Nock. There's a programming language called Hoon. There's an operating system called Arvo. These are some of the core components. You've explained some of them in detail, kind of glossing over them. Can you just explain a little bit more how they fit together, why these are 3 core components that if somebody wants to come at Urbit and sort of understand what Urbit is trying to do, explain like how these 3 things fit together and how they're fundamental to understanding how Urbit works.
Sure. So, I think a good, not everybody knows Lisp, but sort of a good one way to sort of answer this
Everybody
question.
listening, I think, knows what Lisp is.
Everybody knows what Lisp is. I don't actually know. I've never actually programmed in Lisp. I just know Lisp. So the thing is that in a way, sort of the closest reference point in some ways is kind of the old dream of the Lisp machine, which created this great alternate reality that eventually kind of died on the vine, but still was in many ways, the symbolics universe of the 80s was in many ways superior to the Unix experience. And so it's sort of important. It wasn't networked. It had a lot of problems, but it was very fine and very cool and very good. And if you sort of look at the technical reasons why that didn't sort of take off or didn't achieve its promise, I think when you look at Lisp, one of the things that you notice sort of very quickly is that there's this kind of sort of interesting game that sort of Lisp has to play with you, where it's like, okay, Lisp is conceptually very simple. Actually, I don't think the lambda calculus is that simple, but certainly if you go to the Wikipedia page for the lambda calculus, it's pretty long. But it's a pretty simple sort of logical system that actually sort of predates computing itself. It was originally a kind of mathematical system, and it's reasonably simple. And then if you look at like a real Lisp, like Common Lisp or Racket or whatever, basically what they've done is they've taken this very simple core and they've extended it. They've grown a lot of hair on it. So it's like, yes, conceptually, Haskell and Racket and Common Lisp are all based on the lambda calculus at a certain level. That doesn't make them actually compatible with each other in any way, shape, or form, right? And so the thing is that, basically I'm coming at this problem. My background I'm an OS guy. I studied, a long time ago, I was a grad student in OS at Berkeley, and then I was like screw this, I'll go get a real job. But I still think as an OS guy. And so the thing that sort of bothers me when I look at these old Lisp systems is I don't see any layers. And layers are just, the lifeblood of any kind of system software. And so basically, if you can take that simple core layer, make it sort of considerably simpler, and if you sort of look at the kind of the delta from a very simple Lisp to Nock, really the main thing that I've done is I've basically taken name resolution out of that VM kernel and I've kicked it up into user space where it belongs. And so the concept of a function, the concept of a symbol, the concept of an environment or a symbol table, these things don't exist at all in Nock. They get solved at the actual sort of programming language level, which is Hoon. So basically, what enables Urbit to, and what enables, and we use this constantly because we have a live network and we frequently upgrade the OS and even the language over the network, is the fact that you have this sort of constant core, which, I made Nock, runs on this thing called, I had this idea which I call Kelvin Versioning, which is basically to version something rather than counting up in like semantic versioning or whatever, you count down because your goal is to hit absolute zero, after which the thing is frozen and can never be changed. And if you count down by integers, you're really giving yourself an interesting job to solve because you can't run out of numbers, right? So Nock right now is at 5 Kelvin, which is the temperature of liquid helium. I made a cosmetic change to it in 2013, but it's frozen. Like I can't imagine that actually changing, even though I've got 4 more degrees to play with. And so the thing is that if you freeze this kind of bottom layer, which is so semantically simple, it's only, integer operation is increment. Even decrementing is in user space, basically in Nock, which is why it fits on a page. Then you're sort of well prepared to basically go up another level and kind of build the right functional language. Clearly, this is a system based on a lifecycle function. It's clearly, a highly functional system. So we step up another level to Hoon. And I'm like, okay, again, I'm an OS guy. I'm not a languages guy. I've never taken a PL theory class. I don't know category theory. And what I observe in the world of functional languages is basically, here's this technology with a lot of promise. Because, one thing that type functional language people, really hardcore, like Lisp is kind of like a softcore functional language, like a real hardcore functional language like Haskell or OCaml, although OCaml has some imperative components. But let's take Haskell as an example. People will tell you basically, and this is true, that when a typed Haskell program compiles, it is very likely to work the first time. And you're just like, coming that's from the world of, C++ or whatever, you're like, wow, that is a fairly impressive claim. And I've experienced that myself with Hoon, which is, it's sort of very true that you get that benefit. At the same time, with a traditional type functional language like Haskell, you have this sort of horrible problem, which is that the language is basically developed by mathematicians. And mathematicians are these sort of very special breed of people that are very good at manipulating abstractions in their head. And so when they go to teach you Haskell, they basically give you one of 2 alternatives. Alternative number 1 is that you actually learn the math and learn to do the category theory and learn this basically system of notation that isn't really even terribly relevant to most programmers today. And also basically requires you to be someone who's just physiologically capable of getting a math degree from a good quality school. That's basically what you have to, the sort of mental toolbox you need in order to learn Haskell. Then there's this other, to learn it properly, then there's this other way of learning Haskell, which is like the Learn You a Haskell way of doing it, where it's like, forget about it, the type system is a black box, you don't understand, just type the little symbols and it'll come out, the way you want. And some programmers can do okay with that, but that's also something I think that's very uncomfortable for a lot of programmers, sort of thinking of this, this sort of black box underneath what you're doing. And I think that combination has really limited the penetration of functional programming quite a great deal. And so kind of my ambition in building Hoon was to build a language that was kind of sort of the functional equivalent of C in a way. So, C had this, you probably remember Pascal. C had
Sure,
this
yeah.
competitor Pascal, which was a very sort of European style system that like is like, okay, here's sort of the formally what you're doing when you program. But let's look sort of, and let's hide all these ugly, assembly language things that are going on under you. And C made the opposite decision. It said, no, C is going to be basically a macro assembler. It's going to be something that's so, just a sort of very thin layer over what's going on under it. And yet it's going to give you the same affordances as Pascal. And so when I look at Hoon, basically, I think sort of the thing that I'm kind of happiest with in a way is that, the compiler for Hoon is, of course, written in Hoon because, everything has to run inside Urbit, right? And when you look at the transformation between the Hoon abstract syntax tree and Nock, the whole sort of language semantics is basically 2,000 lines of code. And there's really no runtime system worth speaking of. So there's nothing like the transformation from Hoon to Nock is extremely simple. It is a typed functional language. It makes no reference to category theory of any kind. And so despite the fact that it's sort of relatively alien to most people, first being a functional language, second being kind of an alien kind of functional language, the simplicity there, I would say, is much higher. So that's kind of basically the deal with Hoon. Should I move on to Arvo, or is that?
So just to interject, give people some context. So I think we could go really deep on all areas of the engineering, and I think that would be much more than a single show.
Yes.
If people are curious, I mean, this is a giant operating system and a functional programming language at the lowest level, and then you've got this event-driven architecture. So people who are interested in the engineering should go and check it out. But let's talk a little bit about the.
Come chat with us.
Yes.
Like if you have questions, just come hop on. You can do it just via the web. Right?
Yeah, you can go into urbit.org/stream and just talk to us over Urbit.
Yeah. So I mean, beyond the way that the OS itself is built and the different components that underlie the OS, the virtual machine and the operating system itself, what is the developer experience? Like, I can install Urbit on top of Mac OS or any other Unix-based system. Once I install it, I've got this file system, which is an append-only log and a checkpoint. Maybe you can explain what that is, but explain what the developer experience is like. After I install Urbit, what do I do with this? Do I run a web application? Do I build something? Do I just hang out in the file system? Do I message people?
That's a great question. And, to be honest, one of the reasons why we're relatively timid about
Urbit's really good at really one thing, which is letting you play with Urbit.
Yes. Let me. So there's sort of two senses in which I can answer that question. One question is, what is the developer experience like now, and what is the developer experience designed to be? So the developer experience now is basically, I sort of like. There's a sort of desire to basically, evangelize the system, which is what I'm doing now. And then there's this desire to say, hey, this is a fairly rocky experience. Come if you want to play with Urbit and you think this stuff is cool. But, when I actually want people who sort of don't care about the technology to start using it or start, developing on it, it's like, I'll definitely let you know. So
the short answer is really that, you can boot this thing. We have, there's sort of introductory tutorials for learning Hoon and getting the sense of how the system works and little examples and stuff. But the truth is that, the real sort of development work to be done here is really on Urbit itself, getting Urbit to be more stable, more mature. So the people that I think really stick around and hang out, because there is a kind of community element, right? I mean, most of what Urbit is good for is also sort of chatting and sharing your code and so on and so forth. So it's like if you believe that it's possible to sort of reinvent this whole world from scratch, then you're more than welcome to come and talk to us about how that might be done and what sort of needs to be worked on, and the materials to figure out how to productively actually contribute and program and so on do exist, but Urbit is still very, very young, and it's a challenging experience.
So yeah, I mean that's sort of obvious. Let me jump up on a level and talk about what sort of the development experience should be like, and why this basically, where this system is going, and why it should sort of be, in a way, I mean, you have to tie everything back, in a sense, to the fact that if running a personal server was just a matter of getting a DigitalOcean droplet, and, I mean, in theory, a DigitalOcean droplet can do everything that Dropbox and Facebook and all these things, are doing. In practice, it can't. And sort of understanding that difference, I think, sort of, and then connecting that directly to sort of what the developer experience is, is going to become, is sort of the right. It's in a way kind of the most critical question you're going to ask here. So let me try and kind of answer that question in terms of where we're going. One of the things about building server-side software in Linux is that the operating system solves very few problems for you. So you're not just building an app on Linux, you're building a stack. It's a LAMP stack, it's a this stack, a node stack, whatever you've got. You've got a lot of components that need to be wired together to sort of form very, very basic services. And even just sort of collecting that stack is this kind of matter of sort of this ridiculous carpentry that you go through. And that in some ways is, I think, one of the factors that sort of does the most to kind of hold back, or sort of make it impossible to use Linux as a personal server. It's like people have come up with, you can use Puppet and Chef to install. Somebody has like a set of 30 packages you can install to create a personal server with, apt-get install or whatever. And I mean, it's kind of, it's an amazing effort, but it kind of proves the point. And one of the things that sort of makes being a Linux system administrator so hard is basically the fact that every application that you're building kind of has to solve all these problems on its own. And so there's this sort of giant, between the OS proper, between the kernel and your app, there's this kind of giant pile of software. So when you compare that to Urbit, I think the thing that basically jumps out at you is that in Urbit, you're kind of solving all those problems. You're actually kicking those problems to the OS layer. And so when I write a server in Urbit, here are, some problems that I don't have to worry about. So in Urbit, number one, Urbit is a single level store. So I don't have to basically say, okay, here are my data structures. Now here's how I flush them to the DB. Here's how I maintain them in the DB, et cetera, et cetera. Yes, you can save them. Urbit has a revision control system. It's actually a type revision control system that you can, sort of push your stuff out to if you want other people to be able to see them. But just keep your data structures, because this is a single level store. There's no sort of separate, here's how I move my stuff to the database. You get a message from the network. That message is encrypted. It has an identity. That identity is from a limited space, so you don't have sort of infinite. Ideally, the network basically sort of always stays kind of high quality, just because you don't have the sort of problem of infinite numbers of identities, which is what creates spam. But if you need to do a reputation query on that identity, that'll be easy. When you're handling a network operation, let's see, every message is a transaction. That's, kind of fairly nice, basically. So you're writing actually as kind of a transactional service. So this sort of whole complex of app server database basically kind of turns into one thing. And so then let's say you want to use a web API. Well, the service of using web APIs is basically curated by the OS. So rather than saying, I want to use a web API, I need to get an application key for it. I need to manage this, gateway to this service. What do I do if the service API breaks? Instead, you're in a world where, number one, your user can be told basically how to go out and get this key, which is basically kind of sort of connecting his computer to Dropbox to whatever. Usually this is a very simple process. if the driver is to connect you to the Dropbox API change, that's going to be auto-updated basically over the air with your OS. You don't have to worry about that. That's like getting your device drivers updated in, Windows. And so really what we're trying to do is basically create a world where the programmer is just doing the application logic and not all this sort of ridiculous systems programming, really, that you're doing when you build just a regular server web application in today's framework.
Continuous integration gives you faster, safer software delivery. With a continuous integration tool like Snap CI from ThoughtWorks, the members of your team can push changes independently of each other, and they can all see their new builds running against different phases of tests before those changes make their way into production. The fastest moving companies that I've talked to on Software Engineering Daily are all using continuous integration. Snap CI from ThoughtWorks is available to anyone, and if you go to snap.ci/Software Engineering Daily, you can check it out for yourself and support Software Engineering Daily. With just a few clicks, I had my own continuous integration set up for some projects that were just sitting in my GitHub account without continuous integration. I got continuous integration up quite easily using Snap CI. If you want to be that hero at your company that starts moving your organization towards deploying often, more confidently, towards that DevOps dream, start working with Snap CI at snap.ci/Software Engineering Daily. Your coworkers will see you working with Snap CI, and they will fall in love with it themselves. Oftentimes, it takes somebody at a bigger company to go out on their own and say, okay, I'm going to roll out CI even though nobody else at the company is using it, and maybe that hero at the company is going to be you. So check out snap.ci/Software Engineering Daily, and thanks to ThoughtWorks for being a continued sponsor of Software Engineering Daily. It really means a lot. I kind of want to take another step back and talk about this project in a more macro sense, because people could look at this project as a very long-term practical project. People could look at it as a thought experiment, but one way or another, it is a project that people are putting real work into. It has legs, and it is something that is outside of the realm of what most people will consider a normal software engineering project. And what I find interesting about Urbit, and also just reading about some of your philosophies and some of your background, and also tied in with the fact I moved to San Francisco recently, and kind of what I was expecting from San Francisco, what I was really yearning for moving here was an open-mindedness. And there is a lot of open-mindedness. You find people with very extreme and interesting views, but there is also a type of conservatism masquerading as open-mindedness, and in some places maybe that's warranted. It's a good thing, but in other places I find it to be hard to deal with and almost a little bit disappointing, because I expected this to be the San Francisco to be this place of free thought and everything, and I see some of the things that the controversies that you get caught up in as really an embodiment of that. And so I'm just curious, as somebody who's leading a big project, how do you trade off between saying things that you believe that make people feel uncomfortable and restricting your speech so that you can be diplomatic and you can get things done more effectively?
That's that's actually several questions, but let me sort of answer the last one first. Is that I have a very simple rule on really Urbit is just one main as a discussion group is one main discussion group, and my simple and explicitly stated rule for Urbit is that all discourse on Urbit Meta, which is our main discussion channel, must be politically correct, That's something that's a word that's sort of seldom used by those who are enforcing it. And so by enforcing it in that sense, you're kind of making a point that this should be sort of orthogonal to your sort of belief systems in a way. I mean, it's like when I look at, I think that there's a number of different ways in which I could take what you just said. And one of the sort of the interesting points when I look at just, especially even sort of just in kind of the technical appeal, but I think there's also definitely a kind of broader, I mean, you're creating a network, like you inevitably have kind of a vision of the future that's implied there. One of the things I find is that sort of there's an interesting pattern in the age range of people that are attracted to Urbit, and there's kind of a donut hole in a way, is that really the people that are most interested in this are either under 25 or over 40. And the people who are over 40 sort of remember the original kind of vision of the internet dream of like a peer-to-peer network, and they're like, yeah, we could actually do that this time. And the people who are under 25 are like, yeah, wouldn't it be nice if I had an ecosystem that was actually invented in my own lifetime?
But I think there's also you actually, Jeff, you put it really well. Like, I think that there is such a, I think in a way Urbit has this kind of, I think as a community, is a collection of people who hold a similar sort of utopian idea of both like sort of freedom of speech and freedom of thought that you do, that it's possible to basically, be polite and be respectful and without like sort of being seeing the discourse kind of devolve, that it's possible for like that. I mean, I think it's funny that the ideal of San Francisco that you describe is one that I totally relate to. I kind of grew up around here, but I know exactly what you mean. And I think the controversy is we live in the age of sort of extreme controversy, right? And sort of controversy as a tool, and I think the hope from a sort of community standpoint is really that like when you actually engage with real humans who sort of have real actual network addresses that they're responsible for, that people are actually incredibly civil to each other, and that kind of like individual discourse is really important. It's really powerful, and it's still possible potentially.
And it's possible to create kind of a sort of polycentric world order in a sense. Like you can create, I mean, like if you replace you there's definitely a sense that you have, or that I have, that's sort of this kind of world of the modern CompuServes and these kind of big digital monopolies kind of really easily reinforces these kinds of political monocultures and these monocultures of perception. And so there's a way in which these things sort of go together, and I'm talking to basically, someone who's say 28, 30 or whatever. They've sort of grown up in the world of these giant silos, these world of these Facebooks. And if you're technically good, basically those companies generate a lot of money. And so they employ a lot of really talented, sort of excellent people. They do a really good job of the things they do. And so you're basically looking at these people that are sort of very kind of satisfied with the status quo. And that's why I think you use the word conservatism in a way. It's like basically their lifestyle works for them, their job works for them. The whole sort of way in which the world is organized around these services works for them, despite its sort of obvious incipient kind of totalitarianism. And I think that you'll see as those people, who are, 30 become 40 and 50, and if nothing changes, I think you'll see that incipient totalitarianism become much less incipient in a way. And so in a way,
vision is not, I mean, I think always there's like continuously in this kind of realm of basically of like Federalist 10, that basically you want there to be lots of competing factions of ideas, that like a really healthy society has people of very vastly different opinions, who are allowed to sort of congregate and form groups that are separate from one another, but that also sort of overlap in some kind of public sphere.
And if those groups are filtered, they should be filtering themselves for quality. They shouldn't be basically having ideological wars over who gets to filter who. That's something that's really important to us.
So this default, to me, the fundamental sort of rebuke or something is basically that right now we have this very strange world on the internet of a kind of default public broadcast communication or completely private one-on-one email. And it's just a very strange thing that doesn't seem conducive to this sort of polycentric society that we think of, that we actually still have for the most part in the real world. It just really does not reflect.
And I personally, not Galen because he's too young, but I personally remember when we had Usenet, which was really a thing, 30 years ago, and seemed like it was going to turn into that kind of sort of global civilization in a way. And then it just, it failed to, perform the essential function of keeping the barbarians out of the city walls. And so, in a way, it's like, I'm like, yes, we can do this dream.
It's much more complicated than that, actually.
It's much more complicated than that, but that's a good way to summarize it.
But that probably gives you some sense of maybe.
Yeah, I think our feelings on this are very, very similar.
Yeah.
Okay, great. Well, thank you guys for coming on, talking about Urbit and techno-political philosophy. I think Urbit's a really valuable project. At first, I thought it was totally crazy, and then the more I looked into it, the more I had to take it seriously. It just totally reminded me of looking into projects like Bitcoin or Ethereum or these other things where they seem like toys at first, and then you look more closely and you're like, oh, okay, this is something I have to take seriously.
Yeah. I mean, it's got to be.
Thank you, guys.
The thing is that you've got to have that sort of big vision, and then that's got to be tempered by just kind of realism at every level, and that's the way you create something that actually matters. Yeah.
Okay. Well, thank you for coming on.
All right.
Yeah.
All right. Take care, Jeff.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow.